Hi, this is Bharat. So today we will solve problems on wave propagation. So in the first problem session we discussed how to calculate this intrinsic impedance and propagation constants and loss tangents and so on. So here we'll do a problem with a similar kind. So the question gives that there is a lossless medium. So whenever they say it is a lossless medium, it implies sigma equal to 0 for this medium. And the properties are given that the intrinsic impedance is 60 pi, and whereas mu r is equal to 1. So the first thing you need to calculate is, so the magnetic field is given here. Inside the medium, the magnetic field is having both Ax component as well as Y component. So what is the direction of the wave here? So to see the direction of the wave, you need to go for the phase function. So if you see there's omega t minus z, there is omega t minus z. So this indicates the wave is traveling in positive z direction. So the common format is like omega t minus beta z. So from this I can observe that the beta value is 1 here, or 1 radian per meter. That is what I can observe. And intrinsic impedance, because it is a lossless medium, there is no sigma. Intrinsic impedance formula simply becomes square root of mu naught mu r divided by epsilon naught and epsilon r, which is square root of mu naught epsilon naught and square root of mu r divided by epsilon r. Mu r is given as 1, and of course we don't know epsilon r. Okay, this we need to find the value of epsilon r, and the value of this number is nothing but 120 pi. So the total answer is 60 pi, which is given beta is 60 pi is equal to 120 pi divided by square root of epsilon r. So it is nothing but gives you epsilon r as a value of 4. Right. So if epsilon r is 4, then you have 60 pi as your intrinsic impedance. So now the epsilon r. How do you get omega? So you get omega from beta. Beta is equal to omega into square root of mu epsilon. It can be also written as square root of mu naught epsilon naught square root of mu r and square root of epsilon r. This is 1. And square root of epsilon r we already saw, it is 2. And this is nothing but 1 by c. That's what c is nothing but velocity of the light. So beta is 1, which is given here. So from here I can say omega is nothing but c divided by 2 radians per second, that is 3 in 1.5 into 10 to the power of 8 radians per second. So that is omega. So we found epsilon r and we found omega. So the question is, last one is part is to calculate the electric field. To do this, first of all, of course, the electric and magnetic fields are related by eta. Okay, but there are two ways in which you can solve this problem. I'll first go with the easiest way. So this you can see here, because there are two components. It's better. I already told you E by H, electric and magnetic fields are related as eta, but this relationship goes only for the phasor forms. First you need to convert your equations into phasor form, and then you can use this equation. So let me first convert my magnetic field into phasor form. So what is a phasor form of the magnetic field? So the magnetic field phasor form is, I already told you like how to write the phasor forms. We solved some problems. So h bar is nothing but minus 0.1 e power minus j times of beta is 1. So you get z into ax cap plus or minus of j times of sorry, you get minus j 0.5 e power minus jz into a cap. Right, this looks confusing, a bit confusing. I can say, how did we arrive this result? Simple. Let me go step by step. How did I get that result? So minus 0.1. This can be written as e power j omega t minus z. Okay, and I take. Let me write it again. So let me first write the magnetic field equation in time domain. Then I will convert it into frequency domain. It is minus 0.1 cos of omega t minus z ax cap. Whereas see this 0.5 sine, I will write it as cos of omega t minus z minus pi by 2. Right? Cos of pi by 2 minus theta, or theta minus pi by 2 is the same, which is equal to sine of the theta. So it is, I can write it like this. Same sine omega t minus z is written as cos omega t minus z minus of pi by 2. So if you see the first one, if you see the term which is present here, this term can be written as real part of minus 0.1 e power j times of omega t minus z into x cap. In the same way, this part can be written as this one can be written as 0.5, of course real part of 0.5 e power j omega t minus z minus pi by 2 ay cap. Right? So that is how you write it. If you don't want to write real part for the whole thing, you can write it here also. Real part of, okay, the real part of each individual term. I think that looks more understanding. So the plus came here, the plus is plus, and before this part was written like this, and this part was written like this. Right? So there go, you can see. So when you write a phasor form, you basically remove these things, write real part and e power j omega t. But first let me write it, e power j omega t and e power minus j times of z into ax cap plus real part of 0.5 and e power minus j times of pi by 2 e power j omega t power minus j times of z into ay cap. Okay, so if you see this, e power minus j pi by 2 is nothing but minus j cos pi by 2, cos of minus pi by 2 minus sine of so it is e power I theta, right? So e power minus j pi by 2 simply converts to minus j. Okay, so now instead of this e power minus j by 2, I can write minus j. So the phasor notation is simply you remove the real parts and you write the imaginary parts, right? Right. So here is our h bar. So to convert this equation into phasor form, you neglect the real part and e power of j omega t part. So you neglect this e power j omega t's and you neglect these real parts and you write whatever thing is left. So if I write it simply, h bar becomes minus 0.1 e power minus jz into ax cap, right? So that is what is left here, plus or minus j is there, so minus j into 0.5 e power minus jz a by k. So that is what I wrote in the initial statement. So you should be able to write these equations easily. In practice you will achieve it, but this is how you get the h bar equation in phasor form. So I have h bar in phasor form. What I will do is, now I'll try to calculate e bar. How do I calculate e bar? So it's simple. So you need to have the phasor form. Once you have the phasor form, you can get the beta like this. So I'll write the phasor form I have, that is h bar is equal to minus 0.1 e power minus j times of beta, sorry, beta is 1, so it is jz a x cap minus 0.5 or j times of 0.5 e power minus jz a by cap. So this is your magnetic field. So from here you can break it into two parts and you can do it, but let me go with the easy one, that is you have this law like del cross of h bar is equal to, you might write dou d by dou t plus j user, but we are dealing with fields far away from the sources, this all solution, so there is no j, and in fact this equation is phasor form, so dou by dou t should be replaced with j omega. So your Maxwell equation actually becomes like this: del cross of h bar is equal to j omega times of d is nothing but epsilon into electric field. So if you want electric field, simply take curl of the magnetic field. So how do you get the curl of the magnetic field? So to take curl of the magnetic field, so you have to write x cap, ay cap, and az cap. And you know it is dou by dou x, and dou by dou y, and dou by dou z. And this x component is minus 0.1 e power minus jz, y component is minus j 0.5 e power minus jz, and there is no z component. So once you find the curl, you just divide it by j omega epsilon, you will get the answer. So what is the curl for this equation? So you can see these functions are not changing with x or y, so dou by dou x variation is 0 and dou by dou y variation is also 0. So if you do for x component, you get, yes, you get an x component, right? If you do x component, you get the x component as minus of, right, minus of minus j 0.5, and of course you get a derivative with respect to z, so you get again a minus 1 times e power minus jz into ax cap. Of course for ay you can see this goes to 0, and you have of course minus of, right, minus of there are many minus here, because for ay you get a minus, and because this is this minus this one, right, so you get a 0 minus of, and you take minus 0.1 e power minus jz, and derivative with respect to z is a minus 1. Okay, so the whole thing with an ay cap. And if you see az, it's already 0 here, so the remaining thing is 0 0, and there is no az component. So if you do del cross h, this will be your answer. So del cross of h, if I simplify and write this, it is minus j 0.5, right, e power minus jz ax cap plus 0.1 e power minus jz ay cap. That's it. So this is del cross of h. So if you divide this with j times of omega times of epsilon, right? So you need to divide this equation with j times of omega time divided by epsilon. Okay. So if you do it, so if you see for x component, when you divide it by j omega epsilon, omega is already known, which is we calculated it, we got it around 1.5 to 10 to the power of 8, and epsilon is also calculated, epsilon naught and epsilon r. So if you substitute these values and you divide this equation, you get the electric field answer something like right, you'll get the answer for electric field. Basically, if you divide these two, you have omega, you have epsilon also. Epsilon is nothing but epsilon naught into epsilon r, we have epsilon 2. You can divide these values and you will get the answer for electric field in phasor form. Of course, you can convert it into time domain. We saw how to convert things from phasor to time domain also. You multiply with e power j omega t and take real part of it. So this is how we solve this problem. The other way to solve this problem is uh, simply start with your phasor form. H bar is equal to minus 0.1 e power minus jz ax cap, and it is minus j 0.5 minus j 0.5 e power minus jz ay cap. So because this is a wave traveling in z direction, this is a wave direction, okay, then electric field x component and magnetic field y component are related by the relationship eta, whereas electric field y component and magnetic field x component are related by minus eta, because x cross curve gives z, so you get a positive eta, and y cross x gives you a negative z, so you get a negative eta. So if you see, this is your x component and this is your y component. So how do you get electric field is nothing but ex component into ax cap plus ey component into ay cap, right? So what is ex? Ex is nothing but theta times of hy component into ax cap plus for ey is nothing but minus eta times of hx into ay cap. So we calculated eta. In fact, eta is given here, it is 65. So you have hy component and hx component. You can substitute there. Then you will get an electric field answer in phasor form. So to convert it back to time domain, you simply multiply it with e power j omega t and take real part of it. This is another way of solving this problem. Okay, so we'll go to the next one. So the next problem is like here a uniform plane wave is propagating in a medium, and the format of the wave is given, which is like omega t minus beta z, and but here there is an e power minus alpha z. This indicates that there is some losses. In fact, if you see the medium properties, epsilon r is given, mu r is given, and sigma is also there. If there is sigma also, okay, then we have a doubt now. So the material is having some conductivity. I don't know whether the material is a good dielectric material. Means the material could be a good dielectric material, or it could be a good conductor. So which one should I consider? Whether it's a good dielectric or a good conductor? To decide this, I need to use something called loss tangent, sigma by omega epsilon factor. If it is greater than 1, then it is a good conductor. If it is less than 1, then it is a good dielectric. So let me use this one to know whether what. So you have sigma here, you have epsilon here. Epsilon is nothing but epsilon and epsilon r. Only thing which we don't have is omega, but in fact omega is here. Like in this equation, we can see omega is nothing but 10 to the power of 8. radians per second. So we have omega 2, so it's the time to calculate sigma by omega epsilon, right? So sigma by omega epsilon is given by this number. Sigma is 3, omega is 10 to the power of 8, epsilon is this number. Epsilon r is given as 1, so you took epsilon r as 1. This is epsilon naught, this is epsilon naught, this is epsilon r, and this is omega, and this is sigma. You get a number 3339, which is very much greater than 1. This implies that at this frequency, the material which we are seeing is behaving like a good conductor. If it is a good conductor, or in this case, conduction current dominate in this material. So if that is the case, what is the value of alpha and beta? We can calculate the values of alpha and beta, but first of all, uh, the alpha and beta, okay, we'll calculate alpha and beta here. Alpha is equal to beta, which is square root of mu omega sigma, or mu naught omega naught sigma. So this is the value of mu naught, and here is your omega. Okay, and sigma, here is your sigma. Okay, so here divided by 2. Oh, sorry, the mu r is given here, which is equal to 20. So this is mu is actually mu naught into mu r. Okay, so mu r is given for this medium. It's a kind of magnetic medium too. So there is mu naught and mu r. So if you substitute all these values, you get the value for alpha and beta, which is equal to 61.4. Or if I say the units, it is alpha is 61.4 Nepper per meter, and beta is 61.4 radians per meter. So we have the value for alpha and beta. Now it is time to calculate magnetic field. Magnetic field can be calculated from intrinsic impedance, but first of all, to calculate it, we need to convert our electric field into phasor form. But what is the value of intrinsic impedance eta? Intrinsic impedance eta for a good conductor is simply square root of, so this is the formula which I gave you, 2 sigma plus j times of square root of omega mu by 2 sigma. This is intrinsic impedance, or the same thing can be written as square root of omega mu plus sigma at an angle of 45 degrees. Or I can also write it as square root of omega mu by sigma e power j 45 is nothing but pi by 4. Right? So this is what I can do. So you have the intrinsic impedance. So you need to calculate the magnitude of this number to get the total intrinsic impedance. So let me do it. So the magnitude of intrinsic impedance mu omega by sigma, this is mu naught, and this 20 is mu r. So mu r into mu naught gives you mu, and here is your omega, and this is sigma. So you took a square root of it, you get an answer square root of 80 pi by 3. So that is the value of intrinsic impedance. So we have the intrinsic impedance. So how do we calculate the value of magnetic field? So to calculate the magnetic field, first you convert electric field into phasor form. I can write electric field as 2 e power minus alpha z into sine, or this can be written as cos of omega t minus beta z minus of pi by 2 ay cap, or the same thing can be written as 2 e power minus alpha z, real part of e power omega j times of omega t minus beta z minus pi by 2 into ay cap, right? So this can be written as real part of 2 times of minus j, e power j minus pi by 2 is minus j, and e power minus alpha z, e power j omega t, e power minus j beta z into ay cap. We neglect this e power j omega t and real part while writing phasor form. The phasor form of electric field is minus 2 times of j e power minus alpha z e power minus j beta z ay cap. So this is your phasor form for electric field. Once you have the phasor form for electric field, you need to calculate the magnetic field. Okay. A simple way to calculate magnetic field is, of course, you know that E, E cross H should be wave direction. The wave is traveling in positive z direction. If I take a magnetic field, if I take an electric field, which is in y direction, then what should be the direction of h bar so that I can get a z? So it should be minus ax cap, right? So for the magnetic field, I have to fill three brackets, right? So the wave direction is z, so I write e power minus j beta z, and the field direction is minus ax cap. And of course, if I want the magnitude is nothing but electric field magnitude divided by intrinsic impedance eta, right? So what is intrinsic impedance? Or the same equation can be written as h bar is equal to minus 2j e power minus alpha z divided by intrinsic impedance is square root of we got something like 18 pi divided by 3, right? And the angle is e power j pi by 4, okay, and e power minus j beta z, and minus of minus becomes plus ax cap. So you take this one, okay. If we convert this is a magnetic field expression which is in phasor form. If you want to write it in time domain, you multiply it with e power j omega t and take real part of it, you get an answer something like this, okay. So here the values of alpha and beta are also written, okay, and you can see there is a pi by 4 coming in picture here. That is a phase shift between magnetic and electric fields because the wave is traveling a good conductor. So this is how we solve this problem, okay. We will go to the next problem. So if you see this next one here, at y is equal to, the electric field expression is given. At y equal to 0, the electric field expression looks like this: 30 times of cos 10 pi t plus pi by 4 into az cap. So somewhere this equation y equal to 0 was put on, but it was said the wave is traveling in a positive y direction. So I can write the general format as something like this: cos of 10 power 9 pi t minus beta times of y plus pi by 4 in az cap. Means maybe the wave is traveling in positive y direction, so you have a minus beta y. So when you put y equal to 0 in this equation, you get back this equation. So I estimate that this is the general format of my electric field. Now I'll try to calculate what is beta here. So I get omega from this expression as 10 to the power of 9 pi, and epsilon r and mu r are given, and sigma is also given. But before solving this, I don't know what this medium is, whether it is a lossy medium or whether it is a dielectric medium. So to know that, first of all, we'll try to calculate what is sigma divided by omega epsilon. So sigma is given as 10 to the power of minus 2, okay. Omega is given as 10 to the power of 9 pi, and epsilon is nothing but epsilon naught into epsilon r. Epsilon r is 4. So we need to see what is this value, okay. Try to calculate it. So value so you get 10 power minus 2 divided by 10 power 9 pi. Epsilon is 8.85 into 10 to the power of minus 12 into 4. So let me use my calculator here. So I get a 10 to the power of 10 on the top. So it is I think it seems like a number which is less than 1. Let me check. It is 10 divided by 8.85 divided by 5, and it's again divided by 4. So it's very small number, 0.08 or something, right? So which is a number which is very much less than 1. So if sigma by omega epsilon is very much less than 1, then the material is a low loss material. For that material, sigma is given as square root of sigma by 2, alpha is given as square root of mu by epsilon, and beta should be taken as omega square root of mu epsilon. So if that is the case, let me try to calculate beta here. So the beta value is omega is given 10 to the power of 9 pi and square root of mu naught epsilon and square root of mu r and epsilon. So this becomes 10 to the power of 9 pi divided by 3 into 10 to the power of 8 and the square root of is 2. So you have 20 pi divided by 3. So that is your beta, radians per meter. So I have beta, right? And there is one thing other, because there are losses, this number here should also have e power minus alpha times y. Okay, I forgot that in the expression. Because it is a lossy medium, the wave is going to decay like e power minus alpha z. In fact, even if I keep e power minus alpha z here, alpha y, sorry, e power minus alpha y here, we'll write it neatly. Right, e power minus, even I keep y equal to 0, I will get back this equation, right, because e power 0 is simply 1. Okay, so what is the value of alpha? Alpha turns out to be, alpha is equal to, sigma is needed here, so sigma is given as 10 to the power of minus 2 divided by 2 into square root of mu naught and epsilon naught, and square root of mu r by epsilon r, we get a number as 1 by 2, but this is nothing but 120 pi. So that gives you, right, so that gives you alpha as so 30 pi into 10 to the power of minus 2. Okay, so right, so now let us so we have the electric field expression. I mean, we have alpha here, we have beta here, we can substitute these things here and we can get the general expression for electric field. So the question asks for electric field at 1 meter and 2 nanosecond. So it is simple, right? So you substitute t is equal to 2 nanoseconds in this equation, and we have beta, we have y you should put as 1 meter in here. You can calculate the electric field, you get it as something like 2.787 is at cap volt per meter. Okay, we'll solve the next one. So the next one asks how much distance I have to travel to have a phase shift of 10 degrees. So if you see, this number is like cos of omega t minus beta into y plus 5 by 4, right? So if I increase y, this number is going to increase. So it's asking how much distance you have to travel in y direction in order to have a phase shift of 10 degrees. Right? So I can say for every lambda distance, you will have a phase shift of 2 pi. Okay? Or to get a 2 pi phase shift, 2 pi in the sense 360 degrees phase shift if you want. Okay? You need to walk a distance of lambda. But if you want a 10 degrees phase shift, how much distance you need to travel is simply y is equal to 10 into lambda divided by 360, that is lambda by 36. But lambda is nothing but, because beta is written as 2 pi divided by lambda, I can write lambda as 2 pi divided by 36 times of beta. So we have the value for beta. If you substitute the value for beta, you get this distance y as something like 8.325 mm. And the last one, the question asks us how much distance the wave has to travel if the amplitude has to reduce by 40%. So initially, say for example, the wave magnitude is like 30 times e power minus alpha times of y. Okay, at y equal to 0, the magnitude is 30. Okay, at some y is equal to some we'll say some distance d. Okay, this factor should fall by 40%. Okay, so if 30, so it has to reduce by 40%. So if it has to reduce by 40%, so what is 40% of your 40? So it is simply 12. So if you reduce by 12, you get an answer like sorry, 18. So at what distance the magnitude of the field goes to 18? This is what the question asks, right? So you can see because this number is going to oscillate between +1 and -1. The magnitude, when the magnitude goes to this, is only dependent upon this factor. This talks about magnitude. This talks about this. Okay. So at what instant you get this answer? So initially it is 30. So at some y equal to d, so 30 e power minus alpha t should be equal to 18. And if you travel at d distance, this whole number should be converted to 18. That means it is decreasing, amplitude is decreased by 40%. This happens when you take log and take ln on both sides. Then you get minus alpha into d is equal to ln of 18 divided by 30. Or d here is simply minus 1 by alpha ln of 18 by 30. Okay. Of course, you get a negative number for t. It doesn't matter basically. The wave is traveling in some distance d. So y is increasing. So if you take ln of 18 by 30, okay, we'll see what number you'll get. Uh, so let me do it. 18 divided by 30. So I think you get a 0.6. You need to take ln of a 0.6. So ln of a 0.6 looks like minus 0.51. So from there t becomes simply 0.51 divided by alpha. So if you have the value of alpha, you can calculate the distance after which the magnitude of the wave reduces to 40%. So this is how you solve this problem. Okay, so you need to understand what term in the wave contributes to magnitude and what contributes to phase shift. Okay, so we'll go to the next question now. So the next question is, in a non-magnetic medium, an electric field is given, and the question asks for various things. Of course, here is your electric field. Okay, so how do you calculate this epsilon r and eta? We already know from this common format, this is nothing but omega, and this is beta. It's a wave traveling in x direction, and the electric field direction is z cap. Because there is no alpha, it is a lossless medium, I can imagine. So how do you get epsilon r? Here alpha is 0, so beta is given as 0.8, and your omega is given as 2 pi, and mu is a non-magnetic medium, so mu r 1, mu r is taken as 1. Epsilon naught is nothing but epsilon naught into epsilon r. So beta is omega into square root of mu, omega into, you can write it as mu naught, epsilon naught and epsilon r, and mu r is taken as 1. It becomes omega by c square root of epsilon r, but beta is already given, it is 0.8. Okay, and 1 by mu naught c naught, 1 by mu naught epsilon naught can be written as c, and you have omega. So from here you can calculate epsilon r. You get the value of epsilon r as 14.59. Okay, so this you have beta in this equation, you know omega, you know c, you need to calculate this epsilon r. So it is simple, direct answer. So you get the value of epsilon r, and if you want intrinsic impedance eta, how do you calculate? So you have epsilon r. Intrinsic impedance is square root of mu by epsilon for this lossless medium. So mu naught into mu r is there, but mu r is taken as 1, and epsilon r. So mu naught by epsilon naught, square root of mu naught by epsilon naught is nothing but 120 by pi. So 120 pi is written here, and there is your epsilon r. You get intrinsic impedance as 98.7 ohms. So this is the magnetic field. Now the next part of the question is to calculate the time average power. So we saw the expression for time average power. The average power expression goes like half times of real part of E cross H conjugate Poynting theorem. And I told you that when you use this formula, the electric and magnetic fields in this equation are in phasor form. So first let me write this field in phasor form. The phasor form is simply, because there is a sign, you get a minus j. We are doing it a lot of times in this session. So your sign can be written as cos of something minus pi by 2, right? And when you write e power j times of this something minus pi by 2, e power minus j pi by 2 becomes a minus j. So when you write it in phasor form, it simply get a minus 4 j and e power minus j times of 0.8 x az cap. If you have a tough time writing it, it's better you go back to your basics. That is like 4 times of you do it like this. You write this expression as 4 times of cos of 2 pi into 10 to the power of 70 minus 0.8x minus pi by 2 times az cap. This equation can be written as real part of 4 times of e power j 2 pi into 10 to the power of 70 minus 0.8x minus pi by 2 az cap. And in this you neglect e power j omega t term, which is 2 pi into 10 to the power of 70, and real part of it. You get the phasor form equation like this. So you have the electric field phasor form. What you want is the magnetic field phasor form. So how do you get the phasor form for magnetic field? So to get the phasor form for magnetic field, I'll write h bar or something like this. H bar and E bar related by eta. That is what I told you. H bar should have some direction, 3 brackets, e power minus j, and this one. First let us find the direction. So the wave is traveling in. So wave direction is positive x direction, and E cross H should always give you the wave direction. So your electric field direction is az cap. Okay, so if I do a cross product to get an x, what should I do? So to get an x, you need to do, if I do z, y cross z, I will get x actually. But if I do z cross minus 5, I can get an x, right? So in this bracket, the direction is minus ay cap. Okay, and because it is a wave traveling in positive z direction, so you will get minus 0.8 x. Okay, let me do that here. X, and this is the magnitude. So the magnitude of electric field and the magnitude of magnetic field are related by eta. Or I can say simply, this is magnitude of electric field divided by intrinsic impedance eta. What is the magnitude of the electric field? So The thing is, uh, uh, there is some additional phase here, so it is not magnitude. Whatever magnitude term is there here, you divide this term with eta. Okay, so if I divide the term with eta, it simply goes like minus 4j divided by intrinsic impedance e power minus j times 0.8 x minus of minus you get a plus and ay cap. So what we'll do is, to calculate power, you have electric field, you have magnetic field. Take conjugate of it. Magnetic field conjugate is simply minus 4j by eta e power plus j 0.8 x ay cap. This is H conjugate. So once you have H conjugate, you have electric field. We do cross product between these two. What is cross product of Az cross Ay? So Az cross Ay gives you a minus X. Okay, but there is Az cross minus Ay. I think there is a minus Ay term. Oh, sorry. So Az cross Ay gives you minus Ax. So there is a minus Ax. Az cross Ay gives you minus X because you are doing A cross H conjugate. And then you product these two terms. There is minus 4j and minus 4j. It simply becomes minus 16 divided by eta and e power j, e power minus j, e power 0, and this whole thing gets a real part with a half before, right? Which is nothing but this one, power. So the average power here is nothing but half times of a real part. Everything is a real number here. Minus of minus gives you a plus. It is 68 divided by eta ax cap, or it is 8 times of divided by eta ax cap, right? So this is your power. In fact, we have the value of eta also. If you substitute the value of eta, okay, I think you get the answer of eta is 98.7. If you substitute here, we get something around 81.80 ax cap milliwatt per meter square is your average power. This is your average power. Average power is measured in watt per meter square. So now we have the average power. So we got the average power as 81 ax cap approximately milliwatt per meter square. So for every 1 meter square area, this much power is crossing in x direction. That is what this equation is saying is. So here is a question which asks for, if the area region is a 100 centimeter square area and this region is nothing but 2x plus y equal to 5. So how much power is crossing through this region? So if S bar is a density vector, how much watt is going from? So if you want to calculate how much power is crossing through a surface, simply the total power crossing any surface is surface integral of S average dot producted with ds bar. So to calculate ds bar, you need to know the normal of the vector, or simply surface S average dot producted with ds into normal to this surface. So how do you get normal to the surface? Is nothing but gradient of this plane, which is 2x plus y minus 5 divided by magnitude of the gradient 2x plus y minus 5. So if you do this, you get an answer for n cap as 2 times of ax cap plus ay cap divided by root 5. So I have n cap, okay, and what I can see is this S average vector is a constant, 81 ax cap dot producted with ds, and the normal vector is 2ax cap plus ay cap divided by root 5. If I do the dot product, I get an answer like 81 into 2 divided by root 5 into ds. So because this is a constant, you can bring this outside. So this becomes 81 into 2 divided by root 5 into integral ds, which is area of the surface. This is nothing but area of surface, which is given as 100 centimeter square. Okay, so if you multiply all these things, you get this power answer as 72.724.5 microwatts power is actually passing through this region. So